All right, Bismillah ar-Rahman ar-Rahim. Welcome back, everyone, for our 10th webinar session now. And inshallah, today we'll be talking about electrical engineering, and we've got Brother Fawad Munir from Brisbane with us. Welcome, Brother Fawad. Thanks for taking the time out.
Assalamu alaikum. How are you doing?
Wa alaikum salam. I'm very well. Jazakallah for asking. How are you?
Yeah, good too. Jazakallah.
Good to see you again. We go way back, but we'll still I know a little bit about your kind of past from when you moved to Australia and stuff like that, but just for our audience to give them a bit of background, because I think it'll be relevant to your professional life as well. Can you tell us, like, when you moved to Australia, what degrees had you done prior, and what degrees have you done in Australia since?
Yeah, so in Pakistan, I studied telecom engineering. Like I did a undergraduate degree, bachelor's with honors, and after that, I moved to Australia in 2013. And I kind of had to wait a bit before getting into Melbourne University, but I did a master's there, and my master's should have taken me, I think, 2 years, but because I did my undergrad in Pakistan, they didn't really let me, bypass some of the subjects that their own students do. So kind of had to do 2.5. And I figured might as well take 3 and do an exchange semester and just chill a bit as well. So
Enjoy
I
life.
basically did it in 3 years. Yeah.
Yeah.
But yeah, I did my master's in Melbourne Uni here. And yeah, I've been here now for almost 11 years. I'm getting old. Don't like talking about that too much.
Yeah. So what was the master's? Was it called Masters in Electrical Engineering, or was it called Masters in Telecommunication or something of that sort?
So the master's degree was called electrical engineering, and within that you could kind of, in the last year, you could kind of choose the type of subjects you wanted to study. You could do a mixture of like traditional power-based subjects like power system analysis, introduction to power engineering, or you could go a bit more power electronics, or you could do, a bit more control system side of things. So I just kind of did a few of each, really.
Okay.
Instead of like going a particular way. And because I also did an exchange semester, I also kind of got exposure to some subjects that weren't really part of my university here, like medical imaging and, like system device testing type things. So like basically testing on testing, like automating test processes for like, chip testing and things like that, and how to look for failures and things like that. So I kind of got a mixture instead of just going one way, but I think definitely there's room to kind of pick a field and just do a few more subjects in that. But depending on, where you've done your undergrad. So at the time that I studied there, the undergraduate degree in Melbourne Uni was 3 years. And after 3 years, so basically they have the 3-2 model where you do the undergrad for 3 years and then you spend 2 years doing a master's. And,
Okay.
if you studied elsewhere, you basically kind of had to do some of the subjects like I had to in master's differently. So even in your undergrad, I think the undergrad was a bit more normal. So like a Bachelor of Science rather than a Bachelor of Engineering in particular. And then in the last year, they just kind of taught you relevant subjects based on what you wanted to study. So if you wanted to go electrical, you'd probably study a bit more electrical subjects. And but even then, if you don't end up doing that, you end up doing something else, you still have the choice and the option to kind of do those subjects in masters, but then your masters kind of becomes a bit longer. So there's definitely choice. I think there's Melbourne Uni in particular, there's an advantage where you can still kind of take your time, get up to speed with, the types of studies you're going to do at university, and then still make up your mind later if, you are undecided. So it works well like that. But in general as well, because I'm sure some people would have this question as to like why even do a master's degree. I think the Melbourne model is definitely a bit different, where it's almost like a half master's in a way, especially if you do your undergrad from there. For someone like me who did my 4-year degree in Pakistan and then studied 3 years master's here, it was a bit different for me. At least it felt a bit different. But I definitely can see the advantages of doing a master's degree now, because more and more, I think it's less prevalent here in a way in Australia. Because for the longest time, and even when I was going for my master's, I remember, a lot of people telling me you shouldn't go for a master's, you should have just done your bachelor's again, and you're not going to be hired and things like that. But at that time in Europe specifically, there was a big boost. Like literally everyone would do their masters. Anything less, and you wouldn't really be employable in Europe at the time. But I see more of that happening here as well. So I think in terms of future-proofing yourself, it definitely doesn't hurt to go for a master's degree. I think it's definitely a step above, gives you like a more in-depth understanding, irrespective of where you did your undergrad from. I think if you do your undergrad from Melbourne University, then maybe you definitely have to, because otherwise there's no way you're going to be, getting anywhere.
Okay.
But that's kind of how I see it anyway. I think there's definitely value in doing a master's these days for sure.
Okay. So,
Same for like even in US, and I mean it depends on where you want to go and where you see your career going. If you just want to stay here, maybe you can be a bit more locally targeted, but depending on if you want that flexibility, I definitely think a master's is worth it. Plus, you can kind of explore your interest a bit more because you obviously
yeah.
get more variety, and you're not just going, you're not like just going sideways. You also kind of dig down, and like really go deep in some subjects because you kind of study, instead of the normal control systems, you study the advanced control systems. Instead of like the electronic circuit design, you have to like study like advanced electronic circuit design. Like that's how they were called in Melbourne
Yeah.
University, just to kind of separate them. But I mean, definitely the depth that you get from that is, I think, invaluable. You definitely learn a lot more critical thinking skills that way.
All right. So sorry, I want to take it a little bit slower because I don't know as much about electrical engineering, and I'm sure a lot of our high school students would be in the same boat. So to just recap, you're essentially saying it's a Bachelor of Science degree at Melbourne University, where you kind of have a generic degree, but you can do the subjects that are more electrical engineering focused.
In the last year,
yeah, in the last year only, and then you do masters together with it. But do you know about other universities? Can you just do Bachelors of Electrical Engineering and still be employable in what, I don't know, how a 3 or 4 year program, or do you always have to do other universities kind of have the same setup as well with electrical engineering?
So to be honest, I wouldn't know what other universities do now, but at the time when I got in, Monash, for example, in Melbourne, and like other universities in Queensland here, like QUT, UQ, UNSW, they all kind of have a proper 4-year bachelor's degree you can go for. So I think after doing that, you can definitely become employable, as far as Australia is concerned. But more and more, like the job listings that you see, you do kind of see people asking for like a master's degree a little bit now. It's still very little here, but there's definitely a few that you can access if you kind of have that.
All right. So that makes it clear. Good. And now tell me, you mentioned initially at the start of a few different branches or subjects you kind of study, control switch and things like that. Can you just say those again and just explain a little bit about what each of those kind of mean and what kind of things you study and what kind of jobs would you do if you were to, I guess, go specialize in one of those and be that focus of your education?
Yeah, so I think in like maybe that's two questions, because I think getting the job aspect is also kind of tied to the final year project that you undertake, because that does kind of form a big part of what you've done, but it's not really necessary, right? Like you can still go anywhere. After having done my master's degree, I could have entered the field at any level because I was still very much a generalist. But say you study more of the traditional power systems engineering subjects, so they're mostly related to the grid, and there are plenty of jobs for that here in Australia, well, of course, all around the world, because grid has its own particular challenges. So they kind of teach you how to do, different load analysis, how to analyze, this. So like you'll basically be given a circuit that you kind of have to analyze, which is, representing the entire grid in a way. You've got different impedances, like call it resistance, but for like alternating current circuits. And like it kind of becomes its own field. Like you kind of have to deal with a lot of vector math, obviously. Like you're talking phases, and it's just like, a vector pointing this way based on the angle or that way. So based on that, like you can draw a lot of conclusions as to what the load is doing and what the system's doing. Because ideally, like the whole game in grid is you want to keep it stable. Because if you don't keep it stable, you get a brownout or a blackout, and basically people don't have electricity, or things get damaged. So grid is obviously very critical. So that's the kind of stuff you learn. It can be very, at least for me personally, I thought it was very dry as well in some parts. But again, depending on who your lecturer is, it can also be interesting.
So is grid one of the sub focus of study, like a major or minor aspect of a study where it's a branch within electrical engineering, or is it not?
It's a major branch within electrical engineering. So a lot of the distribution, like the power distribution, like there's many companies here in Australia, like Oricon comes to mind. It's a consultancy. There's AECOM, which is the regulator. And like there's other companies that kind of do like substation design. So substations are where you're getting power generated, or like you basically entering the grid at that point, based on whatever generation capability you have, or you're just trying to distribute electricity. So to be able to do that analysis and to understand the grid in real time, because you're dealing with a real-time system, so that's a big thing. When you deal with real-time systems, you can't just make any big errors, because like the system is live, and whatever you do can have ripple effects elsewhere. So in that sense, like it can be a very powerful field, and there's definitely a big job market in Australia if you go down that route. The other one, a big one, is control systems, but that kind of ties into what mechatronics engineering kind of teaches you to be in a way. But mechatronics is you like studying both mechanical and electrical engineering subjects, and you're studying control theory as well, because that's a big thing. But in control systems, just by itself, you're basically trying to maintain a system. It could be any system. Mostly when they teach you, they're trying to teach you like simple robotics, like a simple robotic arm, or like a simple pendulum that you're trying to balance. And through that, they kind of teach you how to keep a system to get to a certain level that you want it to be maintained at. And then there's different models within that. A lot of matrix multiplication. If you like matrices, that's the field for you. But the control side of things is very handy if you are interested in robotics, if you're interested in automation, if you're interested in factories, if you're interested in mining as well. So mining has a big mining is a massive industry in Australia. There are many jobs. They pay really, really well. And yes, you probably need to go live in a town somewhere, or you have to fly in, fly out. But it's a big part, maintaining control systems there. And within control systems, you have PLC programming, which is just a programmable logic controller. It's basically like parallel programming, but I mean at like a proper work level, you're not really doing like that programming every day, to be honest. You're mostly like configuring different parts. You got to understand at a high level what those things do. And then so that's another big market as well that you can access if you study control systems, which is just, it's in a nutshell, it's just trying to maintain a system to a particular value that we want it to be at. So a simple example would be, for example, that in my car, when I drive it, I want to go at 100 kilometers on the freeway. Obviously, sometimes I go over and sometimes I go under. But basically, when I push the pedal, I'm not controlling the speed. I'm controlling how fast the engine is, basically the shaft in the engine is, rotating. And based on that, I get feedback from the car. I can see the speedometer point a certain way. And that's a control system problem, right? I'm trying to get at 100, but sometimes I'm at 99. Sometimes sometimes I try and correct for that. I go over. So that's like the concept of overshoot, undershoot, and a critically damped system where you just kind of hit the perfect thing every single time. And then there's like responses. It's like how quickly you do something. So if I go from 60 to 100 very quickly, yes, my response time was good, but there's a good chance that I would just go over the 100 speed limit. So that kind of thing is a control system problem.
So we've talked about grids, we've talked about control system. Is there one that I've missed that you have explained in there?
So there's a lot more, obviously. So one big one is electronics and PCB design, electronic circuit design, electronic system design. And that is also a big major part in your studies that they teach here. And to be honest, I personally love those subjects very much. So within that too, then you have to be able to program your microcontrollers as well. So there's firmware programming, embedded systems. So embedded systems is basically like you're building a circuit, but it's not just a dumb circuit. It's got a microcontroller that needs to be programmed as well, and it's trying to control something. Then it becomes an embedded system. So basically, all electronics, like your mobile phone and things like that, that would be an example of what that is. And within that, you're trying to design the circuit board, like the green circuit boards that we see if we are lucky enough to break one of our devices. But yeah, like that's a major field as well. And within that there's many nuances as well as to like where you place your components, what components to select, how to start the design, how to lay out the board. It's a bit of an art form. Definitely not an expert in that, but the more you do it, the better you get. And one of the most satisfying projects I think that I did while at uni was for electronic circuit design. But yeah, that involves everything from being able to come up with like a higher level concept of like, okay, this is what I want my device to do, and you kind of like break it down from like a higher level abstraction, and like you go all the way down to component level. And from a component level, once you understand what it is, you kind of select, okay, like this is like, I don't know, I can't really give a good example because the components are so tiny, but like you kind of select, okay, I want a component with a footprint that's like this much, or a footprint like that's this much, depending on how much space you have and what the power constraints are, and what the signals are that are going to go from one place to the other. And whether you've got radios or whether you've got batteries, and heat management, thermal management, EMI, which is again a big thing that you do in as a engineer, as an electrical engineer, is you're trying to chase ghosts basically in the wires. And that's usually down to like some kind of leaky connection somewhere. So electromagnetic interference is a big thing. But that also kind of ties into electronics level. And then a similar field to electronics, electronic system design, is power electronics, with the emphasis being on power because of its particular, like it's got its own challenges. And because of that, it's just like its own field and its own art form. So whereas in normal electronics, you might be using a transistor to amplify something, or you might be using it as a switch. In power electronics, you mostly use big, massive, massive transistors as a switch, as a on-off thing, that you're trying to time in a particular way to ensure like your power quality that you get at the end is what you want. It's not noisy, and you're trying to smooth out power. You're like trying to take the voltage up or take the voltage down, bring the current up or bring the current down, depending on what you need. But you are trying to design a circuit where you can do those things in a clean, smooth way, rather than it, kind of like causing massive spikes and sending big pulses through a system that can potentially damage it. So that's like similar to electronic system design, but kind of becomes its own thing, and it's a big field as well. And again, like there's a combination as well. Like it's not like they're all segregated, so one kind of principle can apply to another. And definitely
so
early on in your career,
a bit of all of them as well, and then but you can kind of focus on one later on, and then be a bit more. That could be one of your specialized kind of area, but you can still learn about all these others that you were explaining.
No, that's not what I meant. What I meant was that, just because, so for example, firmware programming, learning embedded systems, learning about them is still important when you go and design power electronic circuits, because that's also a core part of that. And when you get to power electronics, because you're dealing with higher power levels, you have to deal with heating and cooling as well. So you have to understand, not fully, but you have to understand, a bit about flow rates, a bit about coolants, where the different channels are, how you want to place devices. And basically, as an engineer, when you work out in the field, you need to have a certain appreciation of other fields as well, not just
Yeah.
electrical, obviously mechanical, business, supply chains, and things like that too. But a lot of this stuff that's going to interact with your system becomes really key. So you have to build an intuition about that. That's why that's why going to university for an engineering degree is definitely worth it. I know like some LinkedIn bros and like some people on the internet these days really go after like school, or school doesn't teach me how to do taxes and things like that. But
Yeah.
like there's like massive value in the engineering degrees, definitely.
Yeah.
And
So
yeah.
so all these other things that you're saying, they're interacting fields like mechanical, having knowledge of that, is that something that you get taught when you're doing electrical engineering, or is that something you kind of have to have your own kind of understanding and appreciation of these fields?
So I think you have to kind of build it up yourself in a way, because the course that you'll study can only cover so much.
Yeah.
Definitely as an I think in electrical engineering, I can't remember studying too much about the mechanical side of things, apart
Yeah.
from like the basic physics courses that you take at the start. Um, so yeah, you kind of have to build up your own intuition about it. But at for my electronics project, for example, I designed the board, like I did everything. Like I picked the components, designed the board, laid them out, ordered the parts, got them in, soldered them, tested them, programmed the whole chip. Right, and now I've got a working thing. But then I also had to put it like it was an optional thing for us to go and design an enclosure, like just a simple case, which kind of takes a bit, like not something that I've done before. So I kind of had to learn a bit about Autodesk Inventor, which is like a computer-aided design CAD program. Um, but yeah, I mean, like some things you kind of have to pick up on your own. And like in my first job, for example, I was lucky enough to work in a startup in my first job, which was really excellent because they
Mm.
were kind of modeled after like a Silicon Valley style startup. So like no life outside of work. But it
Yeah.
was really good
Can you
because I
tell us,
learned a
sorry,
lot.
sorry
And
to stop you. Can you tell us a little bit about what job have you had, and tell us what those companies were doing, and what role did you had there as well while you're telling us about it?
yeah, yes, would be a good continuation, I think. But yeah, like in that first job, like we were working on an electric motor, and we're
Okay.
testing them, and there's like a cooling loop, and the guy who's in charge of that is a mechanical engineer who understands like fluid dynamics, which is a big massive thing.
Mhm.
In fact, there's like I think a $2 billion prize for solving one of the equations that no one can solve related to that, if you're
Mm.
interested.
Oh.
Just a separate thing. But
Yeah.
like so like talking with that person, like how he views things, what kind of flow rate, what coolants, like I picked up a lot. And I mean
Mm.
that's the kind of thing. So I think when you're first starting out, instead of like putting yourself in a hole, really talk to everyone around you. I think most people would
Mm.
definitely do that if they're
Mm.
curious about what's going on. So you kind of have
Mm.
to step out of your own little thing and ask other people what they're doing and why they're
Mhm.
doing the things they're doing.
Mhm.
Structure of a thing becomes important too. And like a lot like there's like people that do finite element analysis, which is a full-on mechanical engineering thing. Very boring, I think, personally, but it's related to the structural integrity of parts and like understanding different materials a little bit as well. So you kind of pick that up along the way when you start talking to people and you kind of understand, okay, like steel's, much stronger per like weight or whatever per gram compared to aluminium, but then aluminium's cheaper or like aluminium's easy to mold. So there's all kinds of trade-offs. Like um, one thing you definitely understand about the world as you become an engineer is like you get a better appreciation for how great Allah is as a creator, because there's no trade-offs in Allah's creation, whereas we're always trying to balance something. So there's always a trade-off between what you use and what kind of design you do. So I think that's a very powerful thing.
Yeah.
But yeah, in terms of like the work
So
that I've done, so my
yeah.
unless you have a question
No, no.
related to
So
this.
you said your first job was essentially to do with like electrical motors, and you kind of learned a lot about fluid dynamics, and you were
So the
testing those
fluid dynamics was more like a thing that I learned on the side from the guy who was
from
doing
him.
it.
So, yeah. Yeah.
So this was a startup. They were trying to like take small 12-seater planes and
Mm-hmm.
taking away the traditional engine that was inside it and replacing it with an electric motor. So we were trying to make a
Okay.
small electric plane. And so for that, we basically needed to do everything from the battery all the way to the propeller spinning. And that involved a battery. And then, from that battery, there's like a power distribution box. From that power distribution box, it goes into the inverters. An inverter is just trying to take direct current, like DC power, and converts it into an AC signal for our AC motor, which we used because it was efficient. It was very power dense, so very useful for like a flying plane where removing weight is key. And in front of that motor is a gearbox, and on that gearbox, then you add couplers or whatever, and then you put a propeller on. And from that gearbox, you're running, your cooling system as well off of like a mechanical governor, they call it. But yeah, that was the whole system. And like I said, it was a startup, which was really good because in a startup, there's not that many people. And because they were trying to model of, Silicon Valley style way of working, basically you could go in any area, do anything. The only thing required was, you were curious, you wanted to work hard, and you wanted to learn. So for me, it came at a perfect time, right at the start of my career. I didn't have any, I wasn't married, and I didn't have a kid like I do now. So now it'd be kind of impossible to do that without, sacrificing some bit of my life. But at the time, it was really good because I could go there and like literally spend 12-hour days, sometimes, not even take a day off. I've definitely worked there for like 6 weeks without, a single day off. There were times, but then they also kind of give you that time back later based on, how the project's going. So it wasn't like a crazy thing, but I mean, enough. I've worked enough to get to the point where, I think if you kind of poked me on the shoulder unnecessarily, I might have, potentially given you a really bad stare. Like that's how hard you kind of worked in that place. And literally everyone around you was kind of working the same way. And because it was a niche thing, like even the people who'd done like 10 years in their careers, like mechanical and aircraft engineers, even they didn't know what to make of a particular problem because they just hadn't seen it. And I think I could probably take another tangent here as well, that a lot of us kind of get confused about what experts are and the value of beginners in any field. And experts are really people who've just kind of seen the same problem over and over and over again. And when you get a really new problem that no one's ever seen before, all that expertise kind of goes out the window. They still have an intuition. They still have a good intuition as to how they can solve it, because obviously, the whole universe was made by Lamia, and there's many, many, many similarities between different things. But at the same time, like you all kind of end up on a level playing field. So that was really crucial. So I started as a test engineer there, working on just electric motors. We just have it on a test bench, and there was a dynamometer on the other side, and that was just there to like give it some load so we could test the different parameters of the motor, like spinning at high speeds, no load, spinning at high speeds, high load, spinning at low speeds, no load, spinning at low speeds, high load, and then every in between, because we're trying to model what this electric motor is capable of, because somebody took a design and then produced it and manufactured it, but from design as to what we simulated on a computer versus what it actually does, there's a gap. So we have to try and model that. So that's where I first started. And then I moved on to the systems integration team because they needed somebody who'd worked on batteries before. And luckily for me, in my final year project, I worked on a Formula Student Association electric car in University of Melbourne. And my year was the first year that they did that. So I was assigned to the battery team. And the battery team basically was responsible for like the battery safety, putting the packs together, what cells to use, where to get them from, and then what kind of structure we wanted to put them in, where obviously a mechanical engineer came in. So having had that experience, they put me in the systems integration team. And we had like these battery modules just sitting there. We had a battery management system to control them. So lithium-ion batteries need to be controlled. Because if you can't control them, you can start fires very easily. You can do some really bad things. So I was put in charge of that along with one other engineer to bring that whole system together. So we had to come up with all the safety processes, how we were gonna assemble it, how we were gonna monitor it, where we are gonna charge it, And then within, that there's many different challenges because you're trying to work on all these new things, not enough
Yeah. So
documentation, not enough
essentially,
time, and a lot of pressure there in terms of, when you had to deliver that whole thing. So that's where I
yeah.
started off with. And, we delivered that battery pack. And then within that, there's like, small power supplies, whatever. And then like on the whole test bed, which is called an iron bed, like a standard industry term, where you just have a propeller spinning from the batteries all the way to the propeller. That's
Yeah.
called an iron bed. So yeah, like within that, there's like instrumentation systems. We wanted to control it, obviously, we wanted to control the motor. So like programming a vehicle controller to be able to do that. But of
Yeah.
course, like not on my own separately, like with other engineers who were kind of responsible for that, but like just kind of helping them out,
So
putting
sorry
on
to about
different.
how long was this your whole job experience? And it sounds
So,
very, very interesting. I want to know more
yeah,
about it, but also want to know also for audience, I think their level of knowledge would be similar to mine and don't want to kind of
and then it makes
get them
sense. Yeah, probably kind of
lose in
went
the middle
on
of the
too long.
details.
Yeah.
So just a little bit more broadly, how long did you work there? What kind of other jobs have you had since? And just more broadly, what your role kind of involves in those jobs for our
Okay. Yeah.
brothers to kind of understand if you become an
Yeah.
electrical engineer, what kind of things you do on a more broadly level. And obviously they'll get to learn more of the deeper things when they get into it.
Yeah. So I guess like the reason why I went on a bit long about that was because even within that one company, I did many roles, but I had
Yeah,
that job for about 2.5 years. So,
yeah,
transition to a systems level design engineer, and then basically
yeah,
also kind of did another big thing, which is like wiring design, harness design, producing drawings, producing
yeah.
system level drawings. So things like that. And then also moving on to systems engineering, which is where you kind of have a working system. We had a working system now, and
Mm-hmm.
we wanted to write requirements so we could actually reproduce it in the future as well on the same
Yeah,
lines as to what we tested it.
yeah.
So after that, that was like 2.5 years. I moved to Airbus as a systems engineer, so kind of a continuation of what I did in like the last few months in that
Wonderful.
company.
Yeah.
And Airbus was the complete opposite end of the spectrum for me. So whereas before it was like a very new product,
Yeah, it's
nobody
very
knew
much.
anything about it.
Yeah.
Airbus is like military helicopters that have been there for like 30, 40 years and
Mm,
slowly designed and slowly changed, and everything is slow. And like there's massive requirements from the defense and from the aerospace side of things that kind of slow
mm,
everything down. So a lot
mm.
more document focused, a lot more process oriented, a
Yeah.
lot more like looking into like different documents that somebody wrote 30 years ago, and you're trying to look for requirements like, okay, oh, this system was designed for this. Okay, that requirement
Yeah.
says that or that. So there's like high level requirements, lower level, and then component level. And then you want to test them, obviously. So there's like testing of that too. So it's like very methodical, very detailed as to
Mm,
like how you want to
mm,
test the system. So that
mm,
was
mm,
one, so like complete polar opposites.
mm.
And then I joined, like that was a year and a half. So I don't have a I definitely don't have a good history of staying too long in one place.
Yeah.
I moved on to Volvo trucks.
Yeah.
And Volvo
Nice.
was like in the middle. So it's still like you're still putting on new trucks that are coming through, but
Mm,
it's still iterative because like it's like your car doesn't change too much. Like it's still got four
yeah.
wheels, it's still got an engine, maybe improves a little bit, gets a bit more
Improvement.
posh,
Yeah.
depending
Yeah.
on, what kind of car you go for.
Yeah.
But for the most part, it's the same. But like there's still
Yeah.
challenges in bringing the new system. And for that particular truck, they were trying to do two voltage levels, which for them historically was also troublesome. And
Mm-hmm.
even in this introduced complexity, but that complexity could have been gotten rid of if the brand in America, which was controlling the whole thing, was willing to give us the latest model, but they wanted
Mm-hmm.
to introduce that in America first. So that's another thing you kind of learn in
Mm-hmm.
engineering as well. Like there's many different kind of constraints that you have to work around, and
Mm-hmm.
it's not always necessarily technical. It could be political, or it could be something else that brand is trying to do a certain thing
Mm.
certain way, and that kind of forces your hand, and you got to design this
Yeah.
slightly worse system now because they just they just won't give you
Yeah.
the better product that they already have.
Yeah.
So that was really good as well, and that had a lot of work around understanding the truck, obviously, where different things were going. The one of the
Mm,
big challenges there was they didn't really have standardized models of where each wire ran. So the
mm,
trucking industry, that's also a big industry in Australia, trucks.
mm,
Literally every second truck that rolls off the line has its own thing. Like it's very custom. Like every customer wants their own shiny
mm.
thing. Like this long, move this thing there, or no, I want bigger fuel tanks, whatever. There's many requirements, and because of that, there was a big challenge around like controlling and like understanding what each component did. So because of the big variety and where each component could be on that truck, from like model to model, there's literally like, I don't know, like 40, 50 variants. You had a lot of trouble in terms of like bringing the newer product, because then you're trying to again work out with those same constraints, and like you're trying to model it, you're trying to look at it in like your CAD, like your computer program, where each thing is, and then you're trying to work out, okay, no, this component gets too hot, no, my cable shouldn't go there, or maybe I can place this component over there to show, improve my power quality, things like that. So a different kind of problem. There was also a lot of work around parts optimization as well, because that was a big thing. Like it's Volvo, it's an old organization. They have a lot of parts in the system. So you need to be able to first find if a part already exists. Ideally, you use that. But if it doesn't fit, then you create a new one. You structure it properly so it goes in the right place. Because on the assembly line, so that's another thing you got to worry about now. Like there's an assembly line and trucks are going to be produced. So you have to understand, okay, if I structure it there, there, and there, it would get pulled onto the right variant that I want it to, and not on the other variants that I don't want to. So that was a big thing, because obviously there's plenty of variants. So that was a really, really interesting job as well. I did that for a year. So not that interesting.
Yeah, maximum is a year to 2 years.
So now I've been working at TELUS.
I can already tell like the experience is so diverse that you're moving from, starting from a very new project kind of startup to something very established, and then so on and so forth. Yeah. Anyways, keep going.
So yeah, I think if you do remind me of getting about that too, like whether you want to stay in one company too long and like really go there, or whether you want to move around, I think there's definitely to be said. There's something to be said about that. But yeah, right now I'm working at TELUS. I've been here for a year and a half, a bit over. And over here we've got army trucks. So again, like kind of related to Volvo in a way, but more in a defense environment. But it also kind of combined my skills that I learned in my first job with lithium-ion batteries. So we were trying to upgrade the power system of this kind of 20-year-old truck at this point and introduce new functionality. And by the time I joined, it was like a tail end of the project. So a lot more testing for me, a lot less design, but a lot more communication with suppliers, and trying to work out different problems with, like how the tests went and what we noticed, or if something wasn't reliable. And I guess like one thing worthy of note there is that, for example, the battery system was one supplier. The power management system, that was like a central controller for this new capability in the vehicle, was a different supplier. And within that, there was like a control problem almost. So it's like one system behaved in a certain way, then the other system reacted, then the other system reacted. And based on that, like you saw some components, like go up and down a bit. So like you could visibly hear like the engine go up and down. So solving that problem was a bit of a chicken and an egg, because you could go talk to one supplier or the other. So, making those calls and trying to engage different suppliers, trying to understand where the root cause is, can be pretty challenging as well. So yeah, that was so definitely a different type of challenge. But again, it's a defense company, so things can be a bit slow, but because things are on the ground now, so a lot less a lot less regulations getting in the way. But yeah, that's what I've done so far.
Zakila, that was very, very informative, like to understand like the study side of things and their like a kind of application as well. Going back to, I guess will be beneficial for our audience as to why you decided electrical engineering, how you went through that process of that, and then what would your recommendation be to our brothers thinking about considering electrical engineering as a possible field for them, and how do they kind of go about figuring out whether this is something for them?
Yeah, so I guess there's many different ways of thinking about that too, obviously. But like for me, it kind of happened that my sister, who's like 4 years older than me, she had to get into university. I think I was in year 9 at the time. And she had all these prospectuses from different universities, and I'm just kind of scrolling through, okay, like there's this field, and I'm like, no, I love electrical, right? I just kind of studied what the possibilities were, and I really loved it, mostly because, things kind of move fast. So there's like I think there's like memes as well that kind of are helpful in a way. So in electrical, things move really, really fast, mechanical a
Yeah.
bit slower, and then civil, they still move, like buildings still move, but very, very slow. It's hard to tell.
Yeah.
And like similarly as like the more extra, like it's also kind of a cliche thing, but it generally holds true where like civil engineers are very extroverted comparatively. Then it's the
Mhm.
mechanical engineers, and like the electrical engineers just an introvert trying to work on this small circuit thing. So like depending on, like that can also kind of affect it. But there's definitely truth to that because the way that people work, for example, it can definitely change your own personality as well. Because obviously, like plasticity is a big thing, and your environment definitely affects you. So, if I'm tucked away in a corner, I'm working on a very technical thing, and I'm working there by myself. It's
Mhm.
not a very collaborative thing that I have to do. Mostly, it
Mhm.
wouldn't be that way in a big company anyway. But you
Mhm.
can definitely become a bit more, focused on that, and like you're less social. For example,
Mhm.
like these days roboticists, for example, which is kind of like a sub branch of mechatronics and electrical engineering in a way,
Yeah.
they tend to be very social, right? Because they have to collaborate with each other. It's like very collaborative field. People kind of have to
Mhm.
come together from like many different
Mhm.
fields, otherwise the whole thing is not going to work.
Yeah.
So they tend to be very social. So like there's definitely an element of that too. But in terms of like selecting, I guess what you really wanna, I think you kind of have to understand what your own personality type is too, like what you're good at. Like I know personally, I can be very logical. I can also be very dry at times too, to my own detriment.
Yeah.
But I mean, it doesn't mean you can't have personality. For example, I think
Yeah.
one thing you notice definitely in an engineering firm more, because obviously there's more, like 90% of engineers are men. But you definitely notice, like, the one girl in the office who talks like 10 times more than the average guy, right? Because like girls tend to be more social, right? So it doesn't necessarily mean that just because you end up here, like you're going to be less social. You can definitely be that, but I think depending on
Mhm.
what you're interested in, what the possibilities are, like for me, it's like electronics is magic. It still is, to be honest, to a certain extent, because no one actually really knows how electrons move. There are
Mhm.
theories, they're really good theories that we've kind of accepted. There are good models about those theories that you kind of study and then apply as an electrical engineer. But for the most part, it's magic, right? So for
Yeah.
me, that was an attractive thing. And like things really do move fast. Plus, like you can like I really like the possibility of working on my own side projects by myself. But I mean, you can also kind of do that in other
Yeah.
fields as well.
Yeah.
But definitely, I think
Um,
depending on what your interests are, I think electrical engineering can be very rewarding. I would also say like I think going forward, like there's definitely trends as to like where the field is going. Like there's
Yeah,
I
that
think
was going to be my next
definitely.
question. Actually, what would you recommend for them? Like, because you were talking about robotics and mechatronics and things like that. From your experience and understanding of these different fields, what is your recommendation to go about it?
So I think no matter what you do now, you should be studying some form of machine learning, or at least have an
Mhm.
understanding of that, because it's
Mhm.
kind of a discipline that touches everything. Like even in like so just a example off the top of my head, like in
Mhm.
power electronics, there's a thing called inverter, which turns direct current into alternating current. And
Mhm.
within that, there's like these six or however many switches that are like trying to time in a different way. So there's an application for AI in that to like make them switch more efficiently.
Yeah.
Because depending on what the switching timing is and like when you switch them, like it kind of it has room to kind of mess up your power quality or like improve your efficiency. And at the end of the day, if you can make your system 2% more efficient than the other person in power electronics, that's like a massive deal. Um, it's like a
Yeah.
billion-dollar company almost at that point.
Okay.
So like understanding machine learning is very important. I think no matter where you go, no matter what field you choose.
Mhm.
But I think like there's also other newer fields as well. So like there's biomechanics as well, which I
Mhm.
think kind of takes away from the traditional electrical engineering. But I think there's still like newer emerging fields that maybe in 10, 20 years time, I think we'll see more of. So like there's like bacteria, when they move, they have these things called flagellar motors, for example. And like you literally look at it, it's like, okay, like that's an electric motor, that's a gear, that's like a spigot or, like thing that's now interconnecting and like making it move. And so there's fascinating things around that. And then like there's weird fields, I think slightly ethically, morally questionable as well, of biocomputing, where now there's an actual company that uses like human neurons for computing. But the neurons obviously die after 100 days. But then like there's also fungi as well that I can't remember the name of the fungi now, that they can use for a similar purpose, or they're trying to. So there's emerging fields as well. So like you don't have to be limited to just the traditional fields, I would say. But yeah, electrical engineering, like you can attack a same problem from many different angles. So for example, I think a lot of people would have heard of Elon Musk and Neuralink, for example, the brain-computer interface. So within that, you could be a software engineer programming the thing. You could be an electrical engineer that understands signal processing, where to place the electrode, how to process the signal, what algorithms to use. And you could be an electronics expert, you could be a chip designer, that's all electrical engineering again. So depending on, your interest, you can attack the same angle from many problems. I mean, you could even be a lawyer that focuses on brain-computer interfaces going forward, right? Because that'd be a big thing. It's an ethical dilemma. And then you could be a computer scientist working on the same thing. So depending on what you're interested in, there's still room around like how you want to move and how you want to attack that particular problem. Um, but I would say like within electrical engineering as well, like definitely, I think there's more and more trend towards I think biology and electronics mixing together. I mean,
Yeah.
recently, they installed a artificial heart in Texas as well, which is basically like it uses maglev technology, which is like stuff that electric trains use, like super high speed trains use, to make it more reliable. Because, well, who knew our heart is like a perfect pump that responds very dynamically. For example, simple movement like sitting up from this chair quickly, that is like such a high stress moment for the heart that it was really hard to do something like that. But like now, after working 10-15 years, those guys did it. So I think more and more there's trends towards human and electronics augmentation. There's problems around robotics as well, and like many. So depending on, what you want to do, I think electrical engineering definitely has a massive, massive area that you can cover when where you
Yeah.
want to go. So
That's good. How was the study like? Just very briefly, Brother Fawad, was it quite manageable? Can you work when you're doing it? And at the end of it, do you think you're almost kind of guaranteed a job if you're in Australia, or not really?
I think definitely. I think in Australia, if you study from Australia, you do an
Mm.
Australian degree, yeah, definitely you're
Mm.
gonna find a job very
Good.
easily.
Good.
I think you run into more problems if you've done an overseas degree, because Australians
Yeah.
do tend to discriminate against that. But in terms
Yeah.
of like the workloads, I think like for the most part it's okay. I think masters was hard. It was
Mm.
very hard actually at times.
Mm.
The
Mm.
first year was still okay, but the last years, I think I actually didn't work at all because it
Yeah.
was not manageable.
Yeah.
In like even then, I think I could have studied even more, and
Yeah.
still not like absorb everything that I wanted to, because there was so much to learn.
Yeah.
But yeah,
Your
definitely, I think
tone,
if
your
there's one
tone has
thing,
totally changed. Sorry to remind you of the trauma, but I think it was important.
but like
Yeah.
I think going to uni and like really taking the time to learn these things is very valuable. Like if
Yeah.
there's one thing I would say do not study to ace your exams. It's kind of a
Yeah.
bad advice because grades are important, but like really dive deep into like the things that
Learn.
you're
Yeah.
interested in. Because I probably wasted so much time. I wouldn't say wasted, because I'm just kind of exploring the field and I'm trying to learn about things that I want to learn, and I'm putting all this time in to really get better at certain skills. But
Yeah.
they definitely don't just chase grades. Like do it because you love it. Do it
Yeah.
because you actually want to love it. And I think over time you will enjoy it if you do get into that habit.
Yeah. Perfect. And just a brief idea, Brother Fawad, is like when our brothers they want to do electrical engineering, are there a lot of opportunities to have your kind of go up the ladder? How is the starting pay like? How do you climb up? Can people start their own businesses and things like that?
I mean, definitely you should be aiming to start your own business at some point.
Mhm.
But maybe get a bit of an experience in the industry first, so you
Mhm.
know what problems are there, and like based on that start something.
Mhm.
And depending on your personality type, whether you're a maintainer or a dreamer like me, you might want to go
Yeah.
for the big thing. So,
Yeah.
there's certainly value in understanding where your long-term goals are, because based on that, you then make your decisions. So, for example, I moved from many different companies because my whole thing is I want to do my own thing at some point, and I want to learn as much as I can about different things that kind of interest me. That may
Yeah.
not be the best strategy for you if
Yeah.
you just want to climb up the corporate ladder. Because,
Yeah.
like for example, right now I would be a senior electrical engineer in
Mhm.
my previous company if I just kind of stayed there, right? So it kind
Yeah.
of
Yeah.
cost me a bit, not in terms of pay that much, because I still kind of managed to do that. Like that's one benefit of moving sooner. Like
Mm.
you can definitely do that quickly
Yeah.
anyway. But in terms of like that, senior title, like if that matters
Yeah.
to you, that can
Yeah.
definitely be a big thing. But in terms of like moving up as well, like there's definitely tiers within, um, you kind of start off as a graduate engineer where you're just trying to learn different things depending on the size of the company you work for. And then you get
Mm.
like baseline authority where you can like produce some design artifacts. And the
Mhm.
next level above is like they let you review those documents too that other people have produced because they understand like, okay, you understand how electrical engineering works, you understand how a product works, and you can
Mm.
give your input to like other people as well because you'll do a good job reviewing their design.
Mhm.
And then another step above that is like you get to approve that design. And depending on your company again, like that, there could be another step where now you're responsible for a whole project. Like you could be a
Yeah.
principal engineer. But then there's
Yeah.
also a different path as well if you want to go the management route. Like you could be a lead, team lead, and then move
Mhm.
into the, you could become a senior manager, things like that. But
Yeah.
like if you love the I think depending on what your goals are and how you see yourself and your personality type, like if you're happy with just like the normal 9 to 5 career, which is, not a bad thing in my opinion, depending on how you want to live your life,
Yeah.
you could just stay, in that and like try and progress up, whether it's the technical fields that interest you, whether you want to go the
Yeah.
management route, like both are open. And you can also kind of segue into the project management side of things as well to kind of take it up a notch. And like that can be a different thing, but then you are more looking at the cost, the budget, the schedule, rather than the actual nitty-gritty of the engineering.
Yeah. Yeah.
So that's definitely something you lose. But depending on your interest, there's many different options you can pursue. And in terms of
Yeah.
the starting pay, I think when I first started, it was between 60. I think actually no less. I think some companies do pay a bit less as well, 55 at the
Mhm.
time to 75,000, depending on if you ended up in like one of the bigger companies in their grad programs.
Yeah.
So I think that was the starting one, but I'm not sure whether that's changed too much because I mean wage
Yeah.
growth hasn't been that great over the years.
Mhm.
So probably
Mhm.
something similar, I think you'd be looking
Yeah.
at.
That's awesome. Jazakallah, brother Fawad. Are there any last words, anything that you think is really crucial for the field that I didn't get to ask you or we didn't get to talk about that would be valuable for our brothers, either grade 9, 10, 11, 12 students or otherwise, our brothers wanting to switch a field or do a different degree?
Yeah, so I think I mean it's never really too late to change your mind about what you want to do. I mean definitely do not just say, oh, like I'm 25 now, so I can't do this, or I'm 20 now, I can't do this. Even if I think one really interesting pathway. I mean, maybe it's worth mentioning. Like one of my colleagues used to be an electrician, and then he did his
Mm,
bachelor's and became an engineer. So
mm,
like he had like really specific hands-on skills that I had no idea about. And like he taught me so much about like, different drills, like different bits, different tools. And
yeah.
like in my first job, I kind of got to learn a lot about that hands-on stuff too, which was
Mm,
really important. So I would say like no matter where you are, like even if you do end up becoming an electrician, I think even that's a good path to becoming an engineer
yeah.
eventually. Because you get the satisfaction of, like designing your own things and like actually working at a level where you like, okay, like I'm making a meaningful contribution to the world, right?
Yeah.
Rather than
Yeah.
just like taking somebody's design and like doing the same thing again, like just wrenching your life away, right? So depending
Mm,
on again what you want to do,
mm,
that's certainly a pathway. And I think just be curious in general. I think as long as you want to learn and you are learning, it doesn't matter where you are.
yeah.
I think the thing about Australia is like a lot of companies do very niche things. So like you might end up in a niche industry and
Mm,
you might
mm,
not be able to move that well. Whereas defense is very big, mining is very big.
mm,
So I mean, there's always options. Like even from that niche thing, you can kind of move around eventually. But
yeah.
yeah, whatever you do, just do it really well. And I think like start reading. So this is one of my
Really.
IEEE, which is a electrical engineering society magazines. Like it comes once a
Yeah.
month. I read it, and like they kind of tell you about different, sometimes
Things
weird
happening in the
technologies
field.
as
Yeah.
well. Like
Yeah.
underwater kites and whatever. And like get some good books. of your field. So this is Art of Electronics. I would highly recommend you read something like this, because they
Yeah.
wouldn't really teach you at uni, but this is like all like practical stuff that you do, like how to design your circuits and whatever. So things like that are really important. Like always, keep reading. I read a lot, basically.
Yeah.
That's a
I
lot of
know
my
you do, and
time.
I picked that up from you, and that was
It's to my
you
own
know
detriment, yeah.
no, I don't think so. I think that's
It's
taken you far, and inshallah, I'm sure you know everything that you read and you learn, and I think that's really important. There's one thing of doing a degree. You can have that mindset that I just want to pass the degree and I just want to kind of have this certificate. Where there's another thing, like you were saying, to be curious, to actually want to learn even the things that don't really fall in your domain, to be even curious about them and kind of learn about everything. Because at some point it'll come back, and you know it will benefit you if you kind of gain that knowledge. So you can never go wrong with gaining a bit of extra knowledge about something that is not directly maybe linked to your field.
Yeah,
Well,
100%. Yeah, like what you just said is like so important, because like even in my workplace, when I look at a lot of people, like some of them have just, it almost feel like they've given up. They're like, oh, like I'm happy in this my little box. Whereas if you're
yeah,
like willing to just take that little bit of extra step, like just literally simple things, which are simple things are really hard actually in life, like just
mm,
showing up and like doing your job properly, like going hard at it, people notice that. So um yeah, like you will stand out just by like working hard. And I think
yeah,
one thing that I know, like we've gone over time now, but one thing
no,
that we definitely, I think when you're young, you think, oh no, I'll just I'll work smart, but you don't
yeah,
really know what working smart means, right? So I would
yeah.
say like at 18, if there's one advice I could have given to myself, would be like work really hard, because you have no idea what working smart is, you're an idiot, basically. So I think if you could take away anything from this, it'd be, if you took that, I think you'd go far in life. But yeah, Jazakallah for giving me the opportunity.
Jazakallah, I really, really appreciate your time and sharing, you know, your experience and, you know, obviously, uh, help, you know, with the intention to help our brothers. And I'm really glad that we got to do that. So I hope that our brothers were able to take some points away from this conversation that'll be of benefit for them, inshallah, in years to come. Jazakallah, brother Fawad, for your time. Inshallah, we'll be in touch again.
Jazakallah for having me. Assalamu alaikum.
Assalamu alaikum.